When we talk about AI, it often sounds like it's some kind of magic, right? Like a brilliant algorithm just pops into existence and suddenly a machine can write poetry or diagnose diseases. But the truth is actually way more impressive. An AI breakthrough isn't just one little spark of genius, it's a huge, monumental engineering achievement. So let's pull back the curtain and really explore the massive hidden system that's powering the entire AI revolution.
All right, first things first. Let's get one thing straight. Because the world we live in is already completely saturated with artificial intelligence, a lot of times in ways we don't even notice. I mean it. This isn't some far-off science fiction concept anymore. It's already woven, pretty seamlessly, into the fabric of our day-to-day lives.
Just think about your morning today. An AI probably woke you up, one that's learned your sleep patterns. Then it planned your commute based on real-time traffic data, and it probably even curated the music you listen to on the way. Right now, it's filtering your email, it's tracking your workout on your watch, and it's getting ready to suggest what you should watch tonight. It is the invisible engine of modern convenience.
So, okay, we see the results literally every day. But what is going on behind the scenes? What does it actually take to build these systems that feel so smart and so intuitive? That, right there, is the real story.
To really get today's AI, you kind of have to know where it came from. See, early AI was all built on these really rigid, pre-programmed rules. Like, imagine a translation system that could only work if a sentence was grammatically perfect. You throw in any slang, any typo, and the whole thing would just fall apart. It was brittle. Modern machine learning, on the other hand, is a whole different ballgame. It isn't programmed with rules. It actually learns patterns directly from massive, and I mean massive, amounts of data. And that makes it so much more adaptable and resilient to the messiness of the real world.
Probably the best way to think about building a modern AI system isn't like writing a piece of software. It's much more like planning a super complex space mission. Seriously, it's a multi-stage journey, and it's got a huge support crew. And I think this framing is just perfect. We always hear about the algorithm developers, right? They're the astronauts. They're the ones who get all the glory. But their mission is completely impossible without this vast support system back on the ground. You've got mission control. That's the data scientists managing all the information flow. And then you have the rocket engineers, the infrastructure teams who build the powerful systems that make the whole journey even possible.
And every mission needs a plan. Well, this is the AI lifecycle. This is the roadmap from just an idea all the way to a functioning system out there in the real world. And we're going to follow this plan step by step to see exactly how an AI mission comes together.
So where does every mission begin? With fuel. And for an AI rocket, that fuel is one thing and one thing only: data. A colossal amount of it. I really can't overstate this. You could have the most advanced algorithm in the world, the most brilliant astronaut you can imagine, but without fuel, your rocket is just a really expensive lawn ornament. Without high-quality data, your AI is totally useless. And the scale of the data we're dealing with now, well, it's astronomical. Get this. Over 90% of all the data in the entire world was created in just the last 2 decades. We are literally swimming in raw material, but it's not quite ready to use yet. This is where the data engineers come in. Their job is to take all that raw material and refine it into high-grade rocket fuel. And that means sourcing just a mind-boggling amount of data, cleaning out all the errors and the junk, and then figuring out how to store and manage petabytes of it. I mean, that's enough data to fill millions and millions of filing cabinets. It is a monumental, and let's be honest, an often thankless job. Okay, so once the fuel is ready, it's time for the most energy-intensive part of the entire mission, the launch. In the world of AI, we call this training. To get a sense of the scale here, just look at a model like GPT-3. It has 175 billion parameters. Now, you can think of a parameter as like a single tiny knob that influences the AI's final decision. So training is the process of figuring out the perfect setting for every single one of those 175 billion knobs. So the key thing to get here is that training is not a quick process. It's a brute force effort where the model makes a guess, checks its error against the data, slightly adjusts its billions of parameters, and then does that all over again, millions of times. This takes thousands of specialized processors like GPUs running flat out for weeks, sometimes even months. It is the computational equivalent of a rocket launch. So after that incredible launch, the mission isn't over, not by a long shot. The AI model is now in orbit, and it needs a place to live so it can do its job. This is the deployment phase. And you've basically got a few options for where it can live. You could deploy it to the mothership, that's the cloud, which has pretty much unlimited power, but the trade-off is higher latency, a little bit of a delay. Or it could live on the space station. That's an edge device, like your phone. It has moderate power, but really low latency. That speed is why things like augmented reality filters can work in real time. And finally, it could be on an Explorer rover, a tiny, tiny sensor. This is extremely low power, but it has the absolute highest security because the data never has to leave the device. So choosing the right home means making these really critical trade-offs between power, speed, and privacy.
Which brings us right back to where we started, the people. The success of the entire mission depends on the whole crew, not just the one person in the cockpit. So let's bring it all back to this idea. We've seen the data engineers who refine the fuel and the infrastructure teams who manage the launch. And yeah, while the astronaut might get the headlines, it's the seamless and often totally invisible teamwork of all of these roles that actually gets the rocket into orbit.
So here's the big takeaway. We need to stop thinking about AI as just a bunch of clever algorithms and start seeing it for what it really is, a complex, integrated system. This whole process, from collecting data all the way to deploying and maintaining the model, is a new and absolutely vital engineering discipline. It's the system, not just the algorithm, that delivers the breakthrough.
So the next time your phone suggests a route or your music app creates that absolutely perfect playlist, I want to leave you with a question. Are you going to see the magic of a single algorithm? Or will you see the incredible hard work of the entire mission control, the rocket engineers and the astronaut, all working together to create that one tiny moment of artificial intelligence?